Happy day, everyone. This is Orekoya Olusegun on YouTube. Today, uh, we are going into uh, two topics. The first one is derivation of angle in radian, and the second one is derivation of the circumference of a circle by calculus method. Please, before we go into today's topic proper, don't forget to like, share, and comment on my channel. Thank you. Now, the first topic, which is derivation of radian of a circle. Let's consider this particular circle. Sorry about that. This particular circle, see, this is a circle with center 0 and then the radius. Let's say the radius r. The angle that is sustained at the center, this angle, is the angle, the arc of the circle. Let's call it arc AB, sustained at the center, and the moment the length of this arc equals to the radius of the circle, the angle at the sustained at the center is no longer in degree, it's in radian. And in our elementary mathematics, we are very sure that the length of an arc is actually the fraction of the angle sustained at the center divided by total angle in a circle, which is 360 degrees, times circumference of the circle. And then the circumference of the circle is given as 2 pi r. Theta over 360, that's the length of an arc, is it times 2 pi r. I'm going to derive this formula for the circumference of a circle using calculus in this particular class. But before we go into that, now this angle theta in degree will become angle in radian when the length L become the r, that is the radius of the circle. So in a nutshell, if length become the radius of the circle, then this angle is no longer in degree, it's in radian. Theta radian is angle in radian all over 360 degree times 2 pi r. This r on both sides of the equation can cancel out. We can divide both sides of the equation by the radius of the circle. So cross multiplying 360 with 1 that we have here, we have 360 degree is equal to theta in radian times 2 pi. Cross multiplying, we have 360 divided by 2 pi is our angle in radian. Call it angle 1 radian. By cross multiplying this, we have 360 degree is equal to 2 pi radian. So if you divide both sides by 2, we can equally rewrite this expression as 360 divided by 2 will give us 180 degree. 2 divided by 2 will give us 1. So we have pi radian. So either of these expression can be used in the conversion of angle into radian or radian back into an angle. That's our first topic. The second one is how to derive expression for the circumference of a circle. Now consider this radius of a circle at angle 0 degree. That means no movement. When an angle is 0 degree, the object has not shifted its position. The radius is at position P1 when the angle was 0. When the radius moves to position P2, it will describe an arc DC. DC simply means a very tiny portion of the total circumference of the circle. We can say infinitesimally small circumference of that circle. And this particular portion of the circumference is also known as the arc of a circle. Now, as this radius move from P1 to P2, the angle changes from 0 to up to this the theta. Now, if I bring out the shape in red out like this shape I'm having here is called the center of the circle. So I have the theta at the center and the radius here. Because this DC is a very small quantity, the curve, this curve DC is like a straight line. We can take it as a straight line. This is a P1 and then P2. So in a nutshell, the sector, which is infinitesimally small sector, is the same thing approximately as a straight line. So this curve of the C is same like this straight line DC. The radius remain the same. Then I have the theta at the center. Now, to find the length of this C, we use trigonometry. We know that tan the theta is opposite over adjacent. That is the C divided by the radius. Cross multiplying, I have r tan the theta is equal to the C. But because the theta is very small, tan the theta is approximately equal to 0, and which is approximately equal to the theta. So tan the theta is same thing as the theta. So in a nutshell, I can rewrite the expression here. Instead of writing tan the theta, I can write it as r the theta instead of r tan the theta. So I have r the theta is equal to the C. Now, to get the full length of the circumference, let me write this expression as my DC is equal to r the theta. To get the full length of the circumference, when the circumference is 0 to the full circumference, you integrate this infinitesimal quantity. So we integrate this side too, from 0 when the angle is 0 to 2 pi, the total angle in radian of a circle. This radius is a constant, so I can bring it outside my integration. So I have 2 pi d theta. So this dc, using the limit 0 to c, integrating the c is actually c from when the circumference was 0 to when the circumference is full c. So substituting here the limit inside this, we have c minus 0. Here integrating the theta is theta between the limits when the angle was 0 to the full total angle in a circle, that is 2 pi. So substituting each of the limits inside this bracket, I have r bracket 2 pi minus, when you substitute 0. So 2 pi minus 0 is 2 pi. 2 pi times r, that is 2 pi r. And c minus 0, the circumference, is c. So this is the circumference of a circle. The circumference of the circle is given as 2 times pi times the radius of the circle. I hope we've learned something great in this class. Thank you so much.